This video introduces the DynaGen Rapidcore software, designed for use with DynaGen controllers. While it's possible to configure DynaGen controllers using their built-in menu system, the Rapidcore software offers additional benefits that enhance functionality. This free software simplifies programming and includes features not available on the controller itself, such as downloading logs, saving and editing configurations, and updating firmware. Most importantly, Rapidcore provides a comprehensive overview of your controller's capabilities, presenting everything in a clear and easy-to-follow interface on your computer. The Rapidcore software is designed to run on a PC. Since I use a Mac, I run Rapidcore using PC emulation software, which allows it to function as if I were using a Windows PC. The main difference is that when I connect a controller, my computer asks whether it should connect to my Mac or the virtual Windows 11 machine. Everything else operates the same way. To get started, visit the Aurora generators or Catron website. On the Catron website, navigate to the Support and Resources menu. 1. Under Brands, select DynaGen. 2. Under Asset Types, select Software. Here, you'll find the Rapidcore software listed alongside the controllers it supports. Select the latest version, download it to your PC, and install it. Once you run the software, the initial screen will appear, but no controller will be detected yet. You need to power the controller and connect it to your computer with a USB cable. Once a controller is detected, it will appear in the interface, indicated by a green dot showing it's connected and active. To proceed, I select the controller and choose to read its settings. Which I want to save before making any changes, allowing me to restore them later if needed. I select Read Settings. I choose When Finished, and then select Save to File. I name the file Default, save it to my desktop, and press OK. To open the saved file without altering it, I read it again and choose to open it upon completion. That's it. The process ensures you can safely explore and modify your controller's settings with Rapidcore software. Next, let's look at the Operator Setup section. This is where you can adjust display-related settings. You can invert the display, change the contrast, set the duration before a parameter page scrolls, adjust the rate at which status messages display, determine how long the display backlight stays on after use. You can also configure settings for daylight saving time, select units of measure, and decide if the controller should allow manual starting in addition to auto start. If you're unsure about any option, hover over it for a pop-up description. Additional details can be found in the DynaGen manuals. Many settings can be entered directly, or you can use the plus and minus buttons to adjust the values incrementally. There's also a slider available for making adjustments. Now let's explore the switched I/O input and output options. The controller has inputs that respond to openings and closures. The example wiring diagram shows these. Switched input A is often used for an emergency stop function. B, C, D, and E are used for other switched inputs. Let's look at the switched input C. We use this to auto-start the generator using two wires, one connected to the ground and the other to this sensor input. To set this up on the controller for the auto-start function, we do the following. First, we select the function. Next, we define what will trigger the auto-start feature. I'm going to select Switch to Ground. When switched input C is connected to the ground, the controller will auto-start the generator. When disconnected, it will stop the generator. Let's move on to the switched outputs. We can see on the example wiring diagram that it's common to use switched output A, B, C, and D for driving relays on the relay pack. Here, A is used for the fuel pump or fuel switch. B is used for the glow plugs. C for crank, which is the starter. And finally, D, a spare relay for some other high-power device. I'm not currently using the E and F outputs, but some may want to activate these spare outputs to power devices such as an exhaust fan, alarms, lights, or some other device. You can decide it for what conditions the output will turn on or off under. Now let's examine the sensor menu. First, let's select Battery. Here you can select Battery Recharge. If selected, the controller can automatically start the generator if the battery gets low. Starter batteries self-discharge over time, especially on generators that power the controller, which causes them to discharge quickly. The best way to preserve your battery is to use a charger maintainer instead of quickly charging the battery by running the generator. Quick charges are not good for the battery's lifespan, so only use this feature if you are off-grid or in a situation where you can't keep a charger plugged in full-time. When you enable this function, some new options show up. Start level is the point where it causes the engine to start up. I'll set it to 12.5 volts in this example. Pre-alarm is the time to display a warning on the controller, so you know the generator will start up to perform this function. Duration is the time it should stay running to recharge the battery. This is where we have an issue with this feature, because your engine will run without performing any hard work, like powering your home. It's not good for an engine to do this too often. Now let's look at set points below. This is the point where the controller issues a warning or failure based on the battery voltage level. I'll set my warning at 12.4. I'm leaving the failure point settings disabled. I need my generator to try and start in any condition. High warnings and high failure levels can also be set that may help detect if there is an issue with the battery or charger and overvoltage on the starter battery. Remember, even if you don't want to use the failure alarm, having the warning still activated causes the alarm to be logged, and it helps in troubleshooting in the future to see what happened over time. It is normal to also see a low battery voltage before cranking because often cold start heaters and glow plugs turn on before cranking and put a heavy load on the battery. So we can ignore low battery warnings just before cranking. We use it to know the glow plugs are actually working before cranking when we see a bit of a voltage drop. Low battery voltage during cranking may be set to 8 volts, but the setting depends on the size of your battery and the normal load during heavy periods. Now, we are moving on to the engine speed setting. There are different ways your controller can sense the engine speed. We often use generator voltage on generators because the controller can convert the generator voltage frequency of, say, 60 Hz to 1800 RPM and figure out the rest based on that. Another option is the magnetic pickup, which is often a sensor mounted near the engine flywheel. You can also use J1939 for electronic engines to access information broadcasted over CAN bus. This speed setting is just for the sensor function. It does not change the speed of your engine. Speed settings. Here is where we set the normal speed of the engine. Most generators are 1800 RPM. On smaller air-cooled engines, it may be 3600 RPM. Set points. Under speed and overspeed, warnings and failures are set here much the same way we have set other set points before. If your engine is running normally, it should maintain the RPM and not fall or rise much under different load conditions. Setting up warnings here and failure levels to shut down the engine if those levels are reached can save you a lot of trouble if something goes wrong. We want the engine to shut down if it is overloaded or starts racing. It's just good practice to use warning and failure levels to help protect equipment. If you are using these controllers with electronic engines that drive something other than a generator, you may want to enable this RPM speed control if your engine can use it. This will let you speed up or slow down some engines using the front buttons on the controller. Do not use this on a generator. It may damage equipment that is expected to work at specific speeds. RPM output. Here you can set some action to happen on one of the switched outputs when a condition is met. Here the condition can be overspeed or underspeed. We are going to leave it disabled because we do not need this function in our generators. Next, engine temperature sensors. Here, you can select the signal source for the temperature sensor. We like to stick to the example wiring diagram and use sensor A input. If you have an electronic engine with J1939 CAN bus, you can select that instead. Next is the sensor type. The options are DATCON, VDO, Custom, and the traditional switch, which is closed or open to indicate a failure. You will need to be familiar with your engine to select the correct type of sensor here. Notice the trim offset? This lets you make small adjustments to correct any irregularity in temperature measurements, as some sensors may not be very accurate. If you select Custom, then you have an option to build your own sensor table and define what different measured values mean. Moving on to oil pressure, it's very much the same as the previous settings. Select what input is used, if any, and sensor type, offset, and any warnings. Next, configure the set points. Bypass time is the amount of time to ignore the sensor after the engine starts. Low warning and failure can also be set or disabled here. The values you select depend on what is considered normal or high for your engine. Now let's select the fuel level sensor tab. Again, the settings are very similar to those of the other sensors, where we select the signal source, C in this case, the sensor type and any offset to correct for errors. And next, the set points. Bypass time can be set to ignore the sensor until a set time after the engine has started. Also, we can set the low warning and low failure level. If you use a fuel level sensor in your tank, it's handy to have the failure set to just before you run out of fuel. Many people prefer to have the engine shut off before it starts sucking in air, as this could make restarting it difficult. Therefore, having the engine deliberately shut off and display a low fuel warning is a useful feature. This allows the end user to simply refill the fuel tank and continue using the engine or generator without encountering any issues with air in the fuel lines. Auxiliary sensors. This can be just about anything. Let's assume you have a temperature sensor in a generator room that looks to see if the room is getting warm, and if it does, turn on your own fan. Here is one way we can do it. First, I'm going to select an unused sensor port. I'll use D here. When this sensor reads a high set point, I want an output to turn on a fan. Now I need to tell the controller what type of sensor I will connect to, sensor D. If we select Build Table, we can name and define our sensor type. We will call it Room Temp and create our own custom sensor table. I can now edit the table based on my temperature sensor and the values that represent different temperatures. I don't need to fill in every value, as it can kind of figure out what's in between what I've told it. Next is the active mode. I'm going to select Running. And next, the bypass time. That is how long it should ignore the readings after the engine has started. The display setting determines whether the sensor readings will be shown on the display. Now, under Function Setting and Runtime, we set how long the output for this auxiliary sensor switched output stays active. I'll show you more on this in a moment. I'm now telling it to turn on at 75 degrees and turn off at 75. Now the tricky part. We just set up the sensor and how it operates, but we did not tell the controller yet what to do, like turning on our fan. Here we need to go back to our switched outputs and select what function causes the output to become active. Switched output F is not used here, so I'll select F under Events. So this switched output F is turned on based on the settings we made for the auxiliary sensor on when it becomes active. You can create many different scenarios. Some careful thought should go into it because they can get a little complex. We won't mess around with us for now, and we'll just disable it for this demonstration. We should also disable the sensor as well. If I happen to customize this later, I don't want anything unexpected to happen, so it's best to disable what I'm not using. Note that there are 4 auxiliary sensors you can play around with. Here is where we configure delays and durations during engine startups and shutdowns. After the controller receives a signal to start the generator, it can delay starting by the value you enter here. If you are starting the engine manually using the front run button, you can also set the delay to start running here. We leave this disabled by default. We just don't have any valid reason to not have the controller respond right away in a manual start situation. Preheat mode. This is where we set the condition for when the preheat should turn off. The most common setting is timer. However, you can also use J1939 or a switched input to tell it to turn off. The timer works great for all our applications. Preheat time. Here you can tell the controller how long the heaters should be on before starting the engine. We found that 8 seconds is more than enough for them to heat up without putting too much of a drain on the battery before cranking. Crank time. This is how long the controller can keep the engine cranking during a starting attempt. 10 seconds also works well without overheating the starter or putting too much drain on the battery. Mid-heat time. This is also a glow plug timer, much like the preheat, but this happens during cranking. We find it better to have the starter battery dedicated to cranking than to keep the heaters on. Crank reset time. This is the recommended duration for the engine to rest after a failed start attempt. Allowing a rest period enables the battery to recover and the starter to cool down. Crank attempts. Here you can set how many times the controller will attempt to start the engine. We typically recommend setting it to 3 attempts. If the engine has not started after 3 attempts, making repeated tries can drain the battery unnecessarily. This could also be an indication that there is an underlying issue, so it's best not to keep trying endlessly. Fuel on while resetting. Some engines use an electronic fuel pump and fuel switch to turn on and off the fuel supply to the engine. Turning off this fuel on while resetting saves the battery a bit between starting attempts. RPM disconnect. This setting tells the controller when to stop cranking. If the RPM in this case is over 650, when it's safe to say the engine is started and we should disconnect the starter. Post-heat time. We leave this setting off on our generators. It refers to how long the glow plugs should remain on after the engine is started. This feature can be helpful in extremely cold weather, but most people in those conditions use block heaters or oil pan heaters instead. Only a few engines seem to struggle to stay running after starting successfully. If your engine does have trouble, you can try keeping the glow plugs on for 10 seconds. One reason we avoid using this feature is that it drains the battery quickly, and the battery charging alternator is already working hard enough to recharge your battery after you start the engine. Restart on false starts. If the engine fails to keep running after starting, it is called a false start. This setting determines whether the controller should attempt to start the engine again. Let's leave it on. Engine stall. When the engine appears to have started but keeps running at a very low speed, failing to come up to normal RPM, the oil pressure is really low. We don't want to keep the engine running under this condition, so we enable engine stall so the controller can shut down the engine. Warm-up time. This is a timer that triggers the warm-up output to become active after the set time has been reached. It may be used to turn on a switched output or trigger some other event. You may want to have a fan turn on after a minute, or maybe switch load on after the engine has been running for a minute or two. This is the timer setting for those events. Cool down time. This is also just a timer to trigger an event after the engine has been told to shut down. It is ignored if you manually turn off the engine. Off button function. When we press the off button, some people want the engine to keep running to cool down, or they are concerned that power may be lost again and want to wait for the cooldown period. However, in our opinion, when we press off, we want the engine to turn off immediately without any delays. This is a safety consideration, especially if an emergency off button is not being used. Energize to stop duration. Certain types of engines need a solenoid or fuel switch to be turned on in order to cut off the fuel supply and shut off the engine, and they do so for a period of time to make sure the engine has shut down. This is where you set that duration. If you use this function, then one of the outputs needs to be configured as an energize to stop function. We don't see this type used often, so we have it disabled here. Warm-up idle. You can disable this for generator applications, as engine speed control is often not performed by the controller. Many engines on generators govern the engine speed mechanically or have their own controller to set the engine speed. That may not be the case on engines used for pumps or other applications. You may want to warm up the engine at a lower RPM before it goes up to full speed. If you do use this, there are a few options for how long this condition remains active. It can be based on time, temperature, for preset fast idle engine RPM. Idle cooldown, same as our previous discussion, but this is about the duration the engine should idle after it's been instructed to shut down. This can be detrimental to generators, but might be useful for other applications. Auto idle link. You might be using electronic circuit breakers or ones with a shunt trip. You can safeguard your generator head and loads by using the feature that trips the breaker when the engine is idling and not running at its normal speed. Danger zone. It's the amount of time the controller will monitor the engine speed before disconnecting the starter motor. Longer times may cause grinding or damage to the starter motor. The default here is 0.3 seconds. Now we're going to look at the scheduler settings. Here is how we set up an exercise function to exercise the engine automatically. For this function to work, the controller should also be set to auto mode by pressing the auto button. First, we set the start time. The pre-alarm is the length of time the controller should warn you it is about to start automatically. You can also set the duration here. This is how long the engine should run for. You can set the duration or the stop time. Now we can set if this is a daily event and on what days, or a weekly one, and each week, or perhaps every 2 weeks. Next, you can select when the first date this should all start happening on. Next, this is a bit confusing, but you can also set the weekly scheduler here. You can also add another schedule. Perhaps you want it to run at different times on different days. This scheduler is a great feature. However, we feel it's better suited for applications other than generator use. We believe that running the engine for extended periods without sufficient workload can lead to the accumulation of deposits. It is recommended that you schedule exercises on a transfer switch instead, as it can also auto-start your generator and power your home to give it a proper exercise. When you have power and you switch to generator power, the transition is very quick and it seldom disrupts power to the home. This is far better than running an engine without a proper load. A popular timer is maintenance. This one is often used to track how long the engine has been running since you last reset the timer. We suggest you use it as a reminder to change the oil or to perform other scheduled maintenance based on time only. We often set it for 250 to 500 hours on diesel engine-powered equipment. If you ever see a message on the controller display that says maintenance required or service required, it is because this setting is just reminding you that the time has expired on this timer. In the user menu, you can reset it to restart it again. The Enable Long-Term Run timer keeps track of how long the engine has been running since you manually started it. Manual starting is anytime you press the Run button. When the set time is passed, it automatically shuts off the engine. This function is used to ensure that someone does not forget to turn off a device after starting it. You can also use it to run a device for a specific duration, such as to charge batteries or operate equipment, and have it automatically turn off after the set time has passed. Now let's move on to AC monitor. In this section, we choose the default generator voltage and the type of connection we are using. Please note that this selection does not alter the generator voltage. It simply informs the controller about our expectations for normal voltage and how to display it. We also have set points for what is considered a warning or a failure for both undervoltage and overvoltage, and you can switch these on and off as needed. Again, we need to tell the controller what it should expect as a normal frequency for the AC power in your region. North America uses 60 Hz. Other parts of the world may use 50 Hz. Once more, we have established specific thresholds for what is deemed as underfrequency or overfrequency, along with warning and failure levels that dictate when an engine should be shut off. Keep in mind that frequency is directly linked to the engine's RPM. In a generator, RPM and frequency set points are the same, so set them both the same or use one or the other. If you have the TG410 controller and optional current transformers for current and power monitoring, this is where to set them up. You can enable or disable this feature. Additionally, you can specify the type of transformer you have, for example, 100 to 5 amps or 200 to 5 amps, and adjust the scaling factor to fine-tune it. It's also important to consider the transformer's rating, which in this case is 100 amps each. Instead of being called set points, it's called basic alarms. We can set what the warning levels are and what the failure levels are that cause the engine to shut down. If you use shunt-tripped circuit breakers, you can set them to trip in an overcurrent situation. The same applies to load imbalances. If you need to use your generator for what is considered too little power and are concerned about wet stacking or deposits building up in the engine, you can tell a load bank to turn on or off based on what the controller sees as too little current. The set points let you define when the dummy load should be on and when it can be turned off. We are just leaving this all disabled here, as most of our applications are not using this. AC power display. This setting is only applicable to the TG410 controller when the optional current transformers are used. You can configure the controller to show the power and determine the normal operating parameters for the generator. This will help you establish the set points for overload warnings and failures. Many new electronic engines use J1939 CAN bus data to communicate sensor and engine data to the engine's computer. With the controller reading data from the engine's computer, the need for a direct connection to all the engine sensors is eliminated. This significantly simplifies the installation process. Here we will go over these settings. One setting is the ECM communications failure. Enabling it lets the controller shut off the engine if communications are lost. Auto Power ECM. The engine computer is also known as an ECM, or electronic control module. It is often powered by the generator controller. We use the fuel output for this. We set it here to auto power the ECM so it can turn on and wake up before we try to communicate with it. ECM power delay tells the controller to wait for how long before turning the ECM back on again, so we don't accidentally restart before the ECM is ready. Controller-specific parameters can be broadcast over the same CAN bus data lines. If you are using remote monitoring and control with CAN bus, you would want to transmit more than just engine data. This is where you specify what to broadcast. This is a feature on both the TG350 and the TG410 controllers. Modbus is another popular data format that can be used to access engine and generator data on the DynaGen controller. It's a feature on the TG410, not the TG350. Here you set the device address, baud rate, and what events can be read under Common Events 1 and 2. There is a detailed manual available for both J1939 CAN bus and Modbus if you are interested in learning more about working with remote access and control. Finally, the Other Config menu. Here, you can set a password to prevent unauthorized access to the controller's operational and settings areas. Enable this feature and set your password to restrict changes. You can also set the timeout period for the password prompt before it locks you out again. If your controller has an optional LCD heater, you can enable it for extreme cold weather. However, 99.9% of users don't need this feature, so it remains disabled. The closed-loop control concerns engines used for pumps and how they should function based on external sensors, set points, and thresholds. The user manual describes this feature in great detail. Fuel selection is a new feature not related to any of our generator applications, so we will skip this in this video. That's it. Now, you can save your settings to your computer and store them back in your controller. All the settings we discussed here are also covered in the user manual, which you can download from our website. If this video was helpful, please consider subscribing and give us a thumbs up. Your comments are always welcome, and they help us to make more videos covering topics you find helpful. Thanks for watching. See you next time.